Hello ladies and gentlemen, welcome back to Micron Engine and Machine. I'm your host, Mike Micron. Today we've got a Yamaha cylinder bank here that we need to bore. The customer has brought this to us and he brought us pistons. We're going to go 3 millimeters oversize, which is roughly 1/8 of an inch. And the reason for this is these cylinders are pretty chowdered up. Let's see if we can see down in here. And this is some really deep rust. Two center cylinders are pretty bad. Let's see if you can see that. This one is by far the worst. See if we can add a little more light to it. Maybe that'll be helpful. But anyway, you can kind of see what we're going to deal with here. And there we go. This guy is pretty similar. Now these were all pretty pitted. The customer tried to do some honing on this himself on the two end cylinders that weren't quite as bad, but that really was not helpful. Got a little bit out, but not nearly enough to make a difference. So what we're going to do is set this up in the boring machine, and I think what I'm going to do is start on the worst one. That way we know that the others will clean up. And I'm thinking, just by looking at this, this is easily the worst one. I don't think the camera really shows how bad it is, but it's fairly deep. So we're going to start here and then we'll get going. And what I'm going to do is turn the camera off, set it on a tripod, and then I'll show you how we set this up in the boring machine to, obviously, to bore the cylinders. So let me go set that up and we'll bring you back. Okay, we're back. We're still working on this Yamaha XS 1100 cylinder bank here, and as you saw before, the cylinders were pretty scored up, or not scored up, they had a ton of rust in them. This bike sat for a long time apparently and got water into the cylinders, and of course the rings being steel and the liners or the cylinders being cast, we had some pretty bad rust. But we've already made one pass now with our boring bar here, and here's our tool bit, and we've made one pass at 40 thousandths. We're going actually 3 millimeters, so this is going to be our second pass. We're going to take out 1 more millimeter, and then the last pass, I think we're either going to do 1 more pass or 2. This actually turned out pretty nice. This is nice material to machine, so we may just do it in 1 more pass. So we're going to do this one. We're going to take out 1 more millimeter. Of course, we did the worst cylinders first to make sure they clean up, and actually they cleaned up, pretty much cleaned up at about 1 millimeter. So this pass should clean everything, but the customer has already supplied us with 3 millimeter oversize, actually 3.5. They're 74.5 millimeter, so that's what we're going to work to. And he supplied us with clearance specification. So we're going to do our machining here on the boring machine, and then we're going to take out 4 or 5 thousandths or so in the hone, and that'll give us a good finish on the cylinders. We always try to take out at least 3, but I like to go for 4 or 5, and that way we're sure we get a nice finish. So what we're going to do, as you can see here, the work head here is air floated, and we're going to turn on the power. So what we're going to do is kind of eyeball this, turn off the air, lower the quill into the cylinder. Maybe I should show you this first. And these are the centering fingers. If you can see them down here, these all flop out, and that will center the bar in the cylinder. So what we do is get kind of close and go down into the cylinder. Now we got nice straight cylinders. It doesn't matter where we center really, but we usually go within a ½ inch of the top. You always want to go below whatever ring wear is at the top. but here we're making a second pass. Everything is straight and clean, so we can go up within that ½ inch. So we float the work head and expand the fingers, or leaves as they're called, and then we lock down. The next step, just to verify what we've done, is we'll take a 1/1000 feeler blade and put it between the fingers, or the leaves, and the cylinder bore, and that way we know we're centered. Nice drag here, it won't move. Let's get over here. Kind of tough to get in here sometimes with these little cylinders. Okay, that's tight. And we'll do the one back here. We can feel that that's tight, so we are centered. So that's a good thing. Come up here. We've already set our tool bit to size, and we're going to wipe it off. Want to make sure that there's nothing on the back side of the stop here, chip or anything, because that would change our size. Right now that's not critical because we're going to take more passes, but it's just a good practice, and you know, you practice to win, not to practice. So slide it here in, and then there's a set screw, and here we go. Next thing we want to do is set our speed and feed, and we've got some new carbide. We found a supplier with a knowledgeable salesman who understood what we're doing here, what kind of materials we are machining, and he hooked us up with some really nice carbide. This stuff seems to like speed, and we're not taking any kind of hog cuts here. We're going 40 thousandths or 1 millimeter, so that's not a huge cut, and that's about as much as I like to go with this machine, just because it's my machine, and why add wear and tear to it. I'd rather take 3 light cuts than 1 heavy cut or 2 heavy cuts. So we'll set our RPM, and we'll set our speed, our feed, Alright, we'll start up here. We'll give this just a second to let it run. Make sure all the, because it's kind of cool here in the shop today. Make sure all the oil and gear lube is circulating through the work head, and we're sure everything here is tightened down. So we'll give this a minute to run, let the oil circulate. Kind of like your car. You don't want to just jump in and drive away. Give it a second, let the oil pressure come up, let it circulate, and then you're good to go. Now we've got an engagement button up on top here, which mechanically engages the gears, and we've got our settings to where we like them. We're going to engage at a little bit lower RPM, and then as the tool bit is fully engaged, we're going to step up the speed a little bit. Like I said, this carbide really likes speed, so once we're into the material, we'll go ahead and speed her up, and it gives a really nice finish. Step up that speed here. As you can see, this is an automatic down feed. Speeds and feeds on this particular machine are actually pretty much infinitely variable. We can take a really slow speed, slow down feed. Sometimes we actually do that if it's a 2-stroke cylinder with ports in it. We can actually just kind of tiptoe past all the ports at a nice slow speed, and that way you don't have all that slamming interrupted cut stuff going across the ports. Alright, then we have automatic shut off. We'll let it run, let the tool bit run past the end of the cylinder. It'll automatically shut off. And what I like to do, rather than drag the tool bit back across the machine surface, usually air it up, move the bar back, go to the neutral position, and just retract it by hand. It does have an automatic retract option, but this actually is quite a bit quicker. Remove the tool bit, and then we're going to move to the next cylinder. And there is a little bit of rhyme or reason to what we do here. Again, not going to make a difference because we're going to take another couple of passes here. But I try not to bore adjacent cylinders consecutively, just because it's barely noticeable. It's not hot, it's just a little bit of change in temperature from this side. So we're going to do 1, 2, 3, and 4. That way everything gets a chance to cool off a little bit. Not that it's even hot, but you know, you practice the way you play. So we'll float over here, do the same thing. Down into the cylinder, extend the fingers, float the bar, center up, and try it again. Put our feeler ribbon in here. Sometimes just seeing this one in the back. There we go. So we're tight all the way around, so we're good. We're locked down. Put our tool bit in. And now we're going to do this 3 more times. Kind of get down to where we're somewhat near where we're going to start. As you can see, the tool bit's right here, so we're maybe 1/4 inch, 3/8 of an inch away. Start, engage, and let's do this. You may have noticed on this cylinder, when we got toward the bottom, I slowed it down a little bit, and the reason for that is we got the cylinder protrusion out of the main block here, and it lacks a little bit of rigidity. So we go at that a little bit slower, so it's not surrounded by the aluminum here, and just do it a little slower, and it makes for a better size, makes the sizing more accurate at the bottom. There's really not a lot to see as the machining is going on, because the tool bit is obviously inside the cylinder and you really can't see that. It's down in there. I can't see it standing here either. So there's not a lot to see. Most of the action is in the centering up.